Please, I'm sorry because of net. Please, but let's continue our course. Now we have this kind of, it is how to find the derivative of y, which is equal to sin x. Now about this, excuse me please, it was an issue, big issue please, of network. I'm so sorry. I'm so sorry, dear friends. Now we are going to continue. The course that we are going to deal with, it is about derivative, but mainly we are going to focus on trigonometric relations, their derivative. Are we together there? Now let us continue about derivative on trigonometric functions. I was telling you that, for example, if we have two lines, it means we have vertical. This is a vertical line and a horizontal line. Yes? Let's have, this is a vertical line where we have a vector and the horizontal line where we have, b vector. Now, we need, please, to add those two vectors. What should we do? Please, are we together? We need to add those two vectors. Thank you very much. Emmanuel Nikiza, thank you very much. I'm in class. You're welcome. You're welcome, dear friend. I like also the way you are participating in our class. Now, about those two vectors, how should we make a sum of those two vectors? It means that you have to take the end of this vertical line where we have a vector A, and at the end of horizontal line where we have a vector B, and you join them. Excuse me, another time I will come with a ruler. It means this vector A and vector B, this is their sum. It is A vector plus B vector. Are we together here? So this means that on our vector, on our summation of those two vectors, this is what we call hypotenuse. Hypotenuse side, and this is the remaining parts where we have A and B side. Where then, and we are just made their summation, we get this part which is hypotenuse. So, but on this triangle, you see, when I try to create these two lines, it means we have a right-angled triangle. This is right-angled triangle. This means that, why do we call this triangle is right-angled? It means it is right-angled because here, at the middle or at the intersection of this vertical line and the horizontal line, we have angle of 90 degree. Are we together here? Please, are we together? Likita, excuse me, please, excuse me. Please make a good place because of the internet issue. Now, about this right-angled triangle, we call this side and this one the different names. That is what we are going to see tomorrow. Thank you very much for your flowers or for your heart. Now it is what we are going to see tomorrow, but I should please say something on this. It is what we call opposite side. Opposite side. But this down, which is Horizontal one, it is what you call, it is in comment, adjacent. Adjacent side. Now the line that you have here is what we call hypotenuse. So this is what we are going to see tomorrow, please. It is your big things that we shall share tomorrow. Now back to our two vertical and the horizontal line. Now on the vertical we have x-axis, and here on the horizontal we have also x-axis, but on the vertical we have y-axis. So how should we say that we have here on y, we have any kind of trigonometric, which one? On y we have sine, right? But on x we have cosine. Right? Are we together here? Also here, you see we are in position of left side. Here, right side of our x-axis, what should we have? Who can guess? You see here, down we have negative position. And here, left side of our x-axis, we have negative also, negative position or direction, right? Also here it should be position or direction. Now that is what we are going to focus on. In the different position of cosine, we have negative place or position or direction. We should have negative or minus cosine. Also, in the different position of this sign, it is downward, we have also minus sign. Are we together here? Now, it is what we are going to see by using derivative. Now, the main objective, it is how everyone should be able to see the inverse of any trigonometric ratio. Now, when we are making a derivative on trigonometric ratio, it means we come down like this one. Yes? Down position. It is derivative. Right? When you are making derivative, we come down position. Yes? And you write the kind of trigonometric that you are reaching on. Are we together here? Are we together, please? That is what we are going to apply on this sine x. Now we come down, and we are reaching at this, which is cosine. It means derivative of sine. You come down, please, from here where we have a vertical. We come down up to this line where we have cosine. Means that derivative, yes, we are making a derivative with respect to x, because here we have x, we have to focus or to respect on this x. Derivative of sine x is equal to, here we have sine, the derivative, you come down, right? Derivative of sine down is equal to cosine. Cosine x or cos x. That is what we call a derivative of trigonometric ratios. Now allow me to clean this part. Have you seen, please, this one? Also, when you have given, find the derivative of it is d cosine x over dx. It will be also, we are going to focus on this. We are going to focus on these trigonometric ratios on Cartesian plane. It means derivative of cosine, where we have a cosine, it is at this position, you come down up to here we have minus sine. It is minus sine x. This is how to find a kind of trigonometric ratio. Have you understandable, please? Type in the comment and we should continue. Thank you, Ifro. Thank you very much. We understand. We understand. Thank you very much. Now let us continue. So last time we have seen how should we make a derivative by using definition or first principle. Now today's I am going to show you how should we find the derivative of, right? For example, this is 2x squared. Let me say y is equal to this is 2x squared. Yes? Now we are going to find the derivative of this one. The simple formula, instead of using definition, should apply this derivative of y respect to x. It will be, this is 2x squared, its derivative. Yes? Now, when we have a kind of this formula that we should apply here, it will be, it is, for example, x power n derivative, it will be, we take this n and come here before of this x, and you have to write this x power that n minus 1. Right? Now finally, we should have also this one. It is n times x power n minus 1. This is general formula. It is what we are going to apply here. What is n? What is n here? This is, it is power 2, as you have here. What is n here? Yes, n is equal to this number 2. Now the derivative of this function y respect to dx, it will be, we have this 2, you have to write this 2. Yes, it is a coefficient that you have. It means it is ax squared. Now this you have to write is as a constant number. This is what you have here. This is a constant 1. Then times we have x as what we have here. But x, remember, we have n. Instead of writing x before, firstly we have to write this n and times x as we have here. Power that n is 2 minus 1, then cross the bracket. We still have, it is, this is 4 times x power 1, which is 4x. It means derivative of this one is equal to 4x. Are we together, please? Are we together? Am I going to clean this? Because today I've used only one part. Am I going to clean this? Type in the comment, please. Am I going to clean this one and continue? Tell him in the comment. Thank you very understand, sir. Thank you very much. Now let's see another one concerning to this derivative also. For example, let's have find derivative of y is equal to, for example, we have sine 4x. Yes, we have this is y is equal to sine 4x. So now we are going to find the derivative of this trigonometric equation. So if you have, for example, formula, let's use a formula here. If you have, for example, sine, for example, let's use ax, right? Excuse me. Let's say that y is equal to sine ax. Now its derivative, it should be, it is dy over dx. It means the derivative of this function y respect to over derivative of this x, we are respecting to this x, where we have it in our given function, it will be, you have to take this h, right? It is h, then you make a derivative of this sine h. I have showed you this one, where here we have, it is on y-axis, we have sine, and here we have a cosine. The inverse of this is minus cosine, and the inverse of this sine is minus sine. Are we together there? Now for this, apart from this, what you are going to do at this one, remember the derivative of this sine x. We have a sine, you have to come down, and the derivative of this sine is equal to cosine. Are we together there? It is cosine. Now it is a cosine of ax. This is what we have here, and it is what you are going to follow right now. Are we together? So now let us continue. For the question that we have given is this, right? Now let's have the derivative of sine 4x. As I gave you this formula, it is what we are going to use on the above question, this one. Yes, the derivative of a given function was this function where we have y is equal to sine x, ax. Now its derivative, this a will come before of this and make a derivative of this sine x, where I told you, you have to come down, the derivative of sine is equal to cosine, is what I have written here, and you add this ax. It is what we call the derivative of sine ax is equal to a cosine ax. Are we together, please? Now let us apply our formula in our given question. Now we still have as a solution, we have y is equal to sine 4x. Now the derivative of our given function y, let's over dx, it will be, we have to remember this is a, then we take sine x, where we have the derivative of sine, you come down and we are reaching at cosine. You have to write cosine of this remaining parts for x. Add it together, dear friends. That is how you should apply derivative, or how you should find the derivative of a kind of trigonometric relation. Now let's see. Someone gave me this example. According to what have we seen, you have to find this is find the derivative of y is equal to x power 3 plus cosine of 5x. This is a question that you are going to do. Personally, I don't know whether you should solve it now, right now, but to me, I should take it as a homework. This is a question, please. Yes? Everyone should do this. This one. Find the derivative of y, which is x squared plus cosine of 5x. Please, I invite everyone to do that question. And tomorrow you will give me an answer relating to this question, where I have to remind you that I am going to prepare for you a short assessment or a short test where I am going to see what I gave you were understandable. Are we together, please? Thank you very much. Likita and this Tiger Show, thank you very much. You are a good student, please. Even time you can't go, you always throw. Thank you very much. I was just saying that this is a homework, yes, where it will be submitted tomorrow at that hour we have precised. Also, I am going to prepare a short, or even though it should be a test relating to all contents that you have covered. Are we together? Now, where we shall see the contents that you have covered were understandable. Yes? Are we together? So now I am just going to give you some minutes where we should share or should discuss, and also you have to prepare that test relating to all contents that you have covered in 2 weeks. I think we start in the last 2 weeks. Yes? But tomorrow you have to submit this question. It will be the one which will be started on before continuing another new session or a new content. Right? Please, tomorrow there is a student also who has told me that tomorrow I should come and be with you or be with your friends on my YouTube. Please, you have to allow me to come with him. He needs to be with you tomorrow, please. May I do it, please, tomorrow? You have to allow me. I need your permission, please. Likita, I need your permission. Yes, sir, please. Thank you very much. Also, another things, they told me that I'm just focusing on my students. They told me that they need to be our friends, yes, through my platform where they will come here and try to discuss with you. Also, they should please share with you an email, even a phone number. But oh, I remember other things, special one. I gave you please my email, right? Please, but I missed please any please message from you. What happened? Even though it is somehow difficult, please, you have to tap your email in the comment, yes, and me, I would please try to email you right now. Yes, are we together? Now, what can I do? Are you going to give me your email, or you are going to write me in the box, please? Please, I gave you, please, my email, please. Welcome. It was my own email. Right? For the one who is new, this one it will be a homework which will be submitted tomorrow. Yes? It will be submitted tomorrow also. Remember, I told you that we have a new teacher will come here on our platform where you will share a different contents. Aimana Marigorete. Very understandable. Thank you very much, dear friends. My relative friend, you are welcome. You are welcome. So I was telling my students that tomorrow at 10, 5 o'clock and 10 p.m. we have a class. Also, I gave them this question where it will be submitted tomorrow at that hour. Also, another special things that I was telling to them, it was about how they should please give me their email, because I tried please to send to them my email. Right now, no response that I got from my email. Yes, it was the short summary about what I was telling to them. Thank you very much. I'm Anagoret, I greet you. How are you doing, please? Please tap on like. Goretti, tap on no like, please. Tap on like for those who are new. Please tap in the like and try to write in the comment. Are we together? Please write something in the comment, please. Whether I should see you are in my class, right? Thank you very much. You feel okay. Thank you very much. Good. How are they, your neighbors? Please, we are going to end up. It is because so the issue of network was disturbing me. That's why we are going to end up this today's lesson. So let me say good. And for those who from India, I say Likita, the one from India, please, you are going to sleep right now. I should say goodbye and have a good night. Even those who are in the early morning, let me say that good morning to them. Yeah. And those who are at 6 o'clock and 14 p.m. also, I should say good afternoon, right? So we are going to end up our today's lesson. So let me please invite you at 5 o'clock p.m. Right? Thank you very much. See you. Likita. See you.